Hello students, my name is Professor Muhammad Asim and we are doing ADMath. ADMath for IGCSE students which have syllabus code 0606 and for CIE O-level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we did some questions of past papers from the topic of differentiation. Today we are doing some more questions of the same topic. So if you are new on this channel and if you are new in this topic, kindly first go to my playlist. There is a folder name is ADMath. Watch lectures of differentiation from the chapter number 14 and chapter number 15. I have uploaded all exercises and all questions. Then after watching lectures of the topic differentiation from your course book, you will have good command. Let's have a look this question. A curve is such that y equals to ax square plus b over x square minus 2, where a and b are constants. Show that dy by dx equals to negative 2x 2a plus b over x square minus 2 whole square. This question came in October-November 2012, variant 1-2, paper 1-2. So let's do part number 1. Very easy. Given that the equation of curve is y is equals to a x square plus b upon x square negative 2. We have to prove that the derivative of this function is negative 2x 2a plus b upon x square minus 2 whole square. So in order to find the derivative, you can see this is a rational function, means fraction is given, so we have to apply u upon v formula. What is u upon v formula? Dy by dx equals to v square, so x square minus 2 whole square, this is v square, v as it is, dot means multiply derivative of u. Ax square derivative is 2ax plus derivative of b, constant derivative is 0, so no need to write 0. Negative u times the derivative of v, so derivative of x square negative 2 is 2x and the derivative of 2 obviously is 0. Now simplify it. 2ax multiplied by x square is 2a x cube minus 2 to the 4ax minus 2x into ax square is 2a x cube plus minus minus 2x into b is 2bx upon x square minus 2 whole square is equals to, you can see 2ax cube cancel by negative 2ax cube. The remaining is negative 4ax minus 2bx. So if you take common 2x, it will remain 2 to the 4a, 2a plus 2x is outside, so only one term is left, b upon x square minus 2 whole square. This is what we need. We have to show that in part number 1 Show that dy by dx equals to negative 2x 2a plus b over x squared negative 2 whole square. And we got it. So this is the answer of part number 1. Now move to part 2. What is part 2? It is given that y is negative 3 and dy by dx is negative 10. When x is equals to 1, find the value of a and of b. Very easy. So our derivative is, we just find in previous part, you can see negative 2x 2a plus b upon x square negative 2 whole square. So in this part the value of dy by dx is given, that is minus 10 is equals to minus 2x 2a plus b upon x square minus 2 whole square. Now you can see the value of x is also given in this part. It is given that y is equals to negative 3 and dy by dx is negative 10 when x is equals to 1. So now we will put the value of x is 1. So negative 10 is equals to negative 2, the value of x is 1, 2a plus b upon x square, that is 1 square minus 2 whole square. Simplify it. Negative 10 is equals to 2 ones are minus 2, 2a plus b upon 1 square is 1 and 1 minus 2 is minus 1 whole square. You can also cancel this, minus 2 into minus 10, that is 5. So 5 is equals to 2a plus b upon minus 1 square is plus 1. So this is equation number 1. Now see the next condition. What is next condition? See again, it is given that y is equals to negative 3. So what was our question? What was the value of y in the question? Y is equals to a x square plus b upon x square minus 2. So y is given minus 3 is equals to a, x is given 1 square plus b upon 1 square minus 2. Minus 3 is equals to a into 1 is a plus b. 1 minus 2 is minus 1 and minus into minus 3. Minus 1 into minus 3 is plus 3 is equals to a plus b. This is equation number 2. Now we have two equations, equation number 1 and equation number 2. Solve these two equations simultaneously to get the values of a and b. So equation 1 is 2a plus b is equals to 5. Equation 2 is a plus b is equals to 3. Subtract these two equations. 2a minus a is a, b cancel by b, 5 minus 3 is 2. So the value of a is 2. Put this value of a in any one of the equation. I am putting it in equation number 2. a plus b is equals to 3. 2 plus b is equals to 3, and b is equals to 3 minus 2 is 1. Hence the answer of part 2 is a is 2, b is 1. This is the answer of part 2. You can see it is given that y is equals to minus 3 and dy by dx is minus 10 when x is equals to 1. Find the value of a and the value of b. So we have find the value of a is 2 and the value of b is 1. Hope you understand. Now move to part 3. Using your values of a and b, find the coordinates of the stationary point on the curve and determine the nature of this stationary point. Very easy. This is part 3. First we have to find stationary point. How? Just write the answer of derivative dy by dx, which we have find in part number 1, is equals to negative 2x into 2a plus b upon x square minus 2 whole square. First, we have to put the value of a and b in the given derivative. That is, a is 2 and b is 1. Minus 2x, 2 into a is 2 plus b is 1 upon x square minus 2 whole square is equals to negative 2x. 2 to the 4, 4 plus 1 is 5 upon x square minus 2 whole square. 2 into 5 is minus 10x upon x square minus 2 whole square. Now the first requirement of the question is to find the value of stationary point. How to find the value of a stationary point? Replace dy by dx by 0 equals to, our answer is, after putting the value of a and b, is negative 10x upon x square negative 2 whole square. Simplified, this whole x square minus 2 whole square is divide over here. This should multiply by 0, and something multiplied by 0 is 0. So 0 is equals to minus 10x, and minus 10 should be divided over here from 0. We will get the value of x is 0, because 0 upon something is always 0. This is x is equals to 0. The second step is to put this answer in the given value of y, which is given in the question. The value, the formula or the equation of curve is given ax square plus b upon x square minus 2. So y is equals to a is 2, x is 0 whole square plus b is 1 upon x is 0 whole square minus 2 is equals to 2 into 0 square is 0. So 0 plus 1 upon 0 minus 2 is minus 2 is equals to minus 1 upon 2. Hence stationary point is x is 0 and y is negative half, 1 upon 2. This is the first requirement of part number 3. You can see, using your values of a and b, find the coordinates of the stationary point on the curve and determine the nature of this stationary point. Now we are going to find out the nature of the stationary point. In order to find the nature of the stationary point, we have to take double derivative. So what is our single derivative? Our single derivative we just find in part number 3 after putting the value of a and b, which is negative 10x upon x square minus 2 whole square. So find the double derivative. D square y by dx square is equals to, apply u upon v formula. So v square, v as it is, derivative of negative 10x, which is negative 10, minus of formula u 10x, multiply by the derivative of v. So derivative of x square minus 2 whole square is 2 multiply by x square minus 2 multiply by the derivative of x square minus 2, which is 2x. It is called the derivative of the function. Now no need to simplify this whole, because we have to satisfy the double derivative by the value of x and y. There is no y, so we just take the value of x, which we have find in previous part, that is x is equals to 0. So put 0 where you are seeing x. So x square minus 2, 0 square minus 2 is minus 2, minus 2 square is plus 4, multiply by minus 10, minus minus plus 10, 10 multiply by 0, and this whole 2 into x square minus 2 into 2x, obviously overall 0, because something multiplied by 0 is always 0, upon 0 square is 0, 0 minus 2 is minus 2, minus 2 square is 4, and 4 square. So 4 into minus 10 is minus 40, 4 square is 16. This whole answer is less than 0 because it is negative, and you know, when the answer is negative, the nature is maximum. So the value of x is 0. It is called the maximum point. This is our final answer of part 3. So very interesting question and very important question according to examination point of view. Hope you understand entire question. And this question is question number 11, October November 2012, paper 1-2. The number of question number in the paper is question number 11. So very interesting question. I hope you completely understand this question, all parts. Now we are moving next question. Question number 6. This is question number 6. The rate of change of variable x with respect to t, time t is 4 cos square t. Find the rate of change of x with respect to t when t is equals to pi by 6. Very easy. Rate of change of x with respect to t means dx by dt, which is given 4 cos square t. Now satisfy this value of t with t is equals to pi by 6. Cos t is pi by 6 whole square 4 cos pi by 6. What is cos pi by 6? You can find from your calculator. Root 3 upon 2 whole square 4, square and root cancel, 3, 2 square is 4, 4 by 4, the value is 3. So dx by dt is 3 units per second. Now we have to find dy by dt. Sorry, this is our answer. Rate of change of x with respect to t when t is equals to pi by 6. So rate of change of x with respect to t is equals to pi by 6 is 3 units per second. Move to next part. Part 2. The rate of change of variable y with respect to time is 3 sin t. So dy by dt is given 3 sin t. Using your answer, your result from part 1, find the rate of change of y with respect to x when t is equals to pi by 6. So first we have to satisfy this by sin t. T is pi by 6. Sin pi by 6, you know, 1 upon 2. So it is 3 upon 2. Now write the formula of dy by dx, which is equal to dy by dt multiplied by dt by dx. dy by dt we have find 3 upon 2 multiplied by dt by dx. dx by dt is 3, so obviously dt by dx is 1 upon 3. 3 cancel by 3. The final answer is 1 upon 2, or you may write 0.5. So 0.5 is dy by dx. So it is very easy question. Move to next question. Previous question, question number 6, was very important. This is also important, but as compared to question number 5, this is so easy. Next question. Question number 7. And the previous question is question number, this question, previous question number 6 came in 2012, paper 1-3. Question number 2. Please note down question number 2. See this question, the tangent to the curve y is equals to 5 ex plus 3 e minus x, where x is equals to ln 3 upon 5 meets the x-axis at point P. Find the coordinates of P. So the tangent to the curve means we have to find the equation of tangent. How to find the equation of tangent? First find the derivative dy by dx. This derivative represents the gradient of tangent. 5ex derivative is 5ex. 3e minus x derivative is minus 3e minus x. That's it. Now satisfy this derivative by the value of x. X, the value of x is given. You can see in the question ln 3 upon 5. So 5ex, x is ln 3 upon 5 minus 3e minus x, x is ln 3 upon 5. So 5 ln and e cancel, 3 upon 5 minus 3 e. This negative must be the power of ln, that is ln 3 upon 5 to the power minus 1. So 5 cancel by 5, 3 minus 3 e power ln 3 upon 5, the whole power is negative 1, means 5 upon 3 to the power positive 1. Just take the reciprocal. 3 minus 3, ln and e cancel, so it is 5 upon 3. 3 cancel by 3, 3 minus 5 is negative 2. So the gradient of tangent is negative 2. Now y is equals to 5 ex plus 3 e minus x, because we need, in order to find the equation of tangent, we need x1 and y1. So y is equals to 5 ex, x is ln 3 upon 5 plus 3 negative x, x is given ln 3 upon 5. So y is